Okay, girls, so now we're going to look at the problems that we need to deal with in 3 dimensions. And before we can do that, we need to understand terminology. Now, if we look at moving on from exercise 6.1, which was problems in a single plane view, we're now going to look at a couple of views. This boat could be placed over here, and then you want to see over there up like that. But before we get to that, we need to understand the terminology of elevation and depression. Now, the angle of elevation is, pretend that I am A and I'm standing here on this ledge. If I want to look up at point C, this is my line of sight. This is what my direct line of vision is. I'm standing here and I'm looking up. I have created an angle of elevation between the horizontal line and the line of sight. Okay? Now let me look down at the boat. If I am standing at A, if I'm looking down, this is my line of sight. Do you see that? If I want to understand the angle of depression, it exists between the horizontal, this is your horizontal line, and the line of sight. It's not this angle over here, it's this angle over here. So my angle of depression ends up being the angle between the horizontal and the line of sight, and the angle of elevation is between the horizontal and the line of sight. Here I can create a 90-degree triangle if I bring this perpendicularly down to the horizontal. And here I can also create a triangle. We can figure out this distance that the boat is from the shoreline if I bring this line down here and I make a 90-degree triangle. The other thing that you need to know is this horizontal line and this line over here, they parallel to each other, which means we can use our alternate angles, because if this angle is, let's say, 60 degrees, then this angle over here must be 60 degrees. Okay, that helps us understand parallel lines. The other thing is we can see that the angle of depression, if this line of sight is a perfectly straight line, only if it's a straight line, guys, then this angle of depression will equal to that angle of elevation. So I hope you took that terminology down. It's important. The angle of elevation is between the horizontal and your line of sight, and your angle of depression is looking down, where it's the angle exists between your line of sight and the horizontal. So let's look at example 1. Example 1 shows us that we have a tree that is perpendicular to a horizontal plane BCD. Okay, language-wise, we know what a tree is. We know what perpendicular is. It means it makes a right angle with. But the horizontal plane is something new that you guys need to understand. This over here is, let's say it's a chalk drawing on the ground, or the shadow if I had to put this triangle up. But this is the chalk drawing on the ground. And you can see this shadow of the tree extending all the way down here. Okay, so this is your horizontal plane. This is what you'll find on the floor of the ground. And this is what is basically perpendicular to the ground up in the air. Now it tells us that DC, which is this point over here to here, is 5 meters long. They tell us that angle DBC, that means angle B over here, is 25 degrees. They also tell us that DCB, go follow it, DCB is 28 degrees. And the angle of elevation of A, that's what A is, from B, which means elevation is looking up, that's our line of sight. Where's my horizontal? There's my horizontal. Therefore, this angle over here is 37 degrees. Guys, a lot of times they're not going to give you these types of examples with drawings in your tests. Sometimes you're just going to get the information, and you need to be able to draw this diagram from this information. So Determine the height of the giraffe AD correct to 1 decimal place. Now, if we look at this, this is in a right angle triangle, right? But I've got this angle, and I know I can use trig in a right angle triangle to solve for this length AD. But I don't have any other side lengths. I don't have that side length, I don't have that side length. I can figure out that angle, but that angle is not going to help me figure out this length. So, how do we then do it? Well, we've been given a second triangle. And this triangle gives me a side length and 2 angles. I know I need this side length to be able to work in this triangle. So I need to determine what BD will be for me to use it in this triangle so that I can find out what AD is. So again, I'm looking for BD now. Now BD is opposite to angle C, which is 28 degrees. And we're looking for a side, and we have an angle that is known opposite to a known side. That automatically makes me think, sine rule. So I go and I write my sine rule. I write my what I want to know at the top in the numerator, BD, is opposite to sine C, which will be sine 28, which is equal to the side length 5, opposite sine B, which is sine 25. Once I do that, I want to keep this by itself. This is dividing BD, therefore when I move it across, it's going to times. We end up having 5 times sine 28 divided by sine 25. And you plug that into your calculator and you end up getting 5.554. Do not round off at this point because this is not our final answer. I only want to round off at the end of my question. So now I've got this side length. I can write it in as 5.554 and put it here. And now I've got the adjacent side with the angle, and I'm looking for the opposite. So opposite over adjacent ends up being the tan ratio. So now I go right, tan 37 is equal to AD over BD, opposite over adjacent. I'm looking for AD. I need to get rid of BD. BD is dividing AD. I bring AD up here. I'm going to go up, I bring BD up here. And I know what BD is. It's 5.554. So 5.554 times tan 37 gives you 4.2 meters. Your giraffe, AD, over here, is 4.2 meters high. Guys, pause the video, write down that solution, make sure you understand it before we move on to question 2 or example 2. Okay, example 2. There are only 3 brick goat towers in the world, and one of them is in Fairview Winery in the Paarl in Western Cape. In the diagram, the goat tower AB, you see the goat tower AB, meets a horizontal plane BDC or BCD. Guys, the horizontal plane, pretend that this is a triangle drawn on the floor in front of this goat tower. What do we know about this goat tower? Well, we know that angle BCD is 44.8 degrees, that DB, which is that length over there, is 70 meters. DC, which is this length over here, is 52 meters. And angle ACB is 30.7 degrees. We know that AB lands on this surface at 90 degrees. You see my little 90 degrees. So this triangle here on the left-hand side has got a 90-degree perpendicular line to it, and that one as well. Calculate the height of the tower correct to 1 decimal place. So if we look at this, we want to find out what AB's length is. In this triangle, I have 70 meters, but I don't have any other angle information except for that 90 degrees. In this triangle, I have my 90 degrees and I have an angle over here. So if I can find out what BC is, I can use my tan ratio because it's adjacent over hypotenuse, opposite, to be able to determine what AB's length is. So this triangle doesn't help me. This triangle does help me get to there, but I need side BC. So now let's go look at this horizontal plane. In this horizontal plane, what can I do to get side BC? I've got an angle over here. I've got two sides, and that's including an angle. Remember when we went through our cosine rules? If I've got two sides and an including angle, I want to use my cosine law, because then I can determine my unknown length, BC. So I always write that first. Length BC squared is equal to the other two sides squared added together, so 70 squared plus 52 squared, minus 2 times the two sides multiplied together, cos the angle opposite the side that we want to know. Okay? I plug all of that into my calculator, and I end up getting BC is 49.379 meters. Again, we do not round off now, we only round off at the end. They did say 1 decimal place. We'll talk about that decimal place now, okay? Now that I've got BC, it becomes a normal trig question, guys, that you're so used to doing. It becomes opposite over adjacent. There we have the opposite AB over the adjacent BC. BC is dividing. I bring it up this side. It's going to times with my tan 30. BC is 49.379. Times that with tan 30.7 degrees. And you end up getting 29.32 meters. Now, to 1 decimal place, we look at that point over there, it's below 5, therefore 3 remains. We do not push it up 1 decimal place. 29.3 meters. Guys, pause the video, write down that question, and then you can start exercise 2 from your textbooks.